Good morning, sir. Myself, Harini. My roll number is 23401A0441. My branch is ECE section. And today my topic is Introduction of Digital Circuits, Combinational versus Sequential. Subject name is Digital Circuit and Designs. Subject code is 233 ECE 303. My topic Introduction to Digital Circuits, Combinational versus Sequential. And title is Introduction to Digital Circuits, Combinational versus Sequential, and presented by V. Haranya, and today date is 9/11/2024. And first of all, what are digital circuits? Digital circuits are electronic circuits that operates with discrete voltage levels. They use binary signals to present data typically in zeros and ones. These circuits are fundamental in computers and various electronic devices. The importance of digital circuits is that digital circuits are crucial for modern computing and communication systems. They enable efficient processing and storage of data. Their reliability and robustness make them suitable for various applications. Overview of digital circuits types. Digital circuits are broadly classified into two categories: combinational and sequential. Combinational circuits is a produce output based slowly on current input. And another definition is a combinational circuit is depends only in uh, present input only. Sequential circuit is a both the current inputs and past past inputs to generate the output. And what are combinational circuits? What are combinational circuits? Is a combinational circuits are a logic circuits and whose output depends on a current input, and these are used for arithmetical operations, data routing and decision making process. Common example includes adders, multiplexers and encoders. Basically, arithmetical operators is addition, subtraction, multiplication, division. And characteristics of combinational circuits: there are they have no memory elements. In combinational circuits, there is no memory elements and no feedback and no concept of clock cycles. And the output changes immediately with the change in the input. When the input is changes, the output is automatically changes. And the combinational circuits can be represented using truth tables, logic diagrams or boolean expressions. And the combinational logic circuits is classified into three types: arithmetical and logical functions, and data transmissions, and code converters. And arithmetical operators is addition, subtractors, comparators, PLD. And the data transmission is a multiplexer and demultiplexer, encoders. Code converters is a binary, BCD, 7 segments. And applications of a combinational circuits. Applications of a combinational circuits. Combinational circuits are widely used in calculators for arithmetic functions. They are essential in digital signal processing for data manipulations. Combinational logic is also used in decision making circuits like multiplexers. And in applications of combinational logic circuits is a NAND and NOR implementations. Multiplexer is a circuit that has multiple inputs and only one output. At any time, one of the input is selected to output based on the value on the select lines. Below is the truth table and 4 to 1 multiplexer. Implementation applications. Example: input to PC. Next one, what are sequential circuits? Sequential circuits are a logic circuits whose output is depends on the current input and past states. They incorrupt memory elements like flip-flops to store informations. These circuits are crucial for timing and control in digital systems. And the characteristics of sequential circuits: the output can change only on specific conditions, often driven by clock signals. They exhibits behavior that can be described by state diagram and state tables. And sequential circuits can be classified into two types, synchronous and asynchronous. And this is the sequential circuits. And in sequential circuits, the clock is also there, and input levels and output pulse levels. And in the sequential circuits, the feedback is contains feedback also. And applications of sequential circuits. Sequential circuits are used in terms counters and registers in counters. They enable the functioning of infinite state machines in various applications. Memory devices like RAM and ROM are built on sequential logic principles. RAM is a random access memory, and ROM is a random memory. Applications of sequential circuits, shift registers and flip-flops, analog to digital and digital to analog converters, counters, clocks, and used as registers inside microprocessor and controls to store temporary informations. Combinational versus sequential. This differences, the combinational circuit has no memory, and while sequential circuits has a memory element. The output of combinational circuit is immediate, whereas sequential circuit has delayed output due to stored states. Combinational circuits are a simplifier and faster, while sequential circuits are more complex but essential for certain applications. And the combinational circuit is outputs only depends on the present input. The output depends on the present input and output in sequential circuits. And the combinational circuit memory element is absent, and the sequential circuit memory element is present. The combinational circuit is no clock signal is applied, and the sequential circuit clock signal is required. An example is full adder, half adder, multiplexer. And example of the sequential circuit is flip-flops, counters, registers. And summary of the combinational circuit is, a combinational circuit is provides the output based slowly on current inputs. They are vital for arithmetic and logical operations in digital devices. Understanding these circuits is a foundational for designing more complex systems. And conclusion of the future directions, both the combinational and sequential circuits are fundamental to digital technology. Advancement of advancement in circuit design continue to enhance performance and efficiency. A thorough understanding of both types is essentially for aspiring engineers and technology. Feel free to customize any of the contact it. And in this summary of the sequential circuit is, a sequential circuits are essential for applications requiring memory and state retention. They play a crucial role in controlling the timing and the sequence in digital systems. Their design is more complex but enables capabilities that combinational circuits can't offer. Thank you, sir.